For nonlinear functions, we will first look at local extrema. Here we have a graph of temperature by time of day. We're going to estimate the minimum and maximum temperatures for this graph. We can see that our minimum occurs right about here, around 5 o'clock in the morning, and the temperature appears to be about 62 degrees. The maximum, if we were to estimate this value up here, looks like it occurs around 3 in the afternoon, and the temperature appears to be about 85 degrees Fahrenheit. Note that our answers here for the minimum and maximum value were really coming from the y-axis, even though we could identify both an x and a y coordinate for each point. So we would say that we used values from the y-axis to answer this question. Now, the values on the x-axis can also be answers to questions, but that would be a different question. For example, at what time did the minimum temperature occur? We might want to estimate that to be around, actually I'm going to say about 4 a.m. because it looks like that label is between the tick marks right about where that point occurs. So let's say 4 o'clock a.m. And the maximum temperature I think we decided was around 3 o'clock p.m. Here we would use values from the x-axis. In this context, it's fairly obvious which values we want to use to answer the questions. As soon as we go to a more abstract context, it's not as obvious, so we want to be able to compare to what we saw here to figure out which is the more natural number to use to answer the question. For a brief summary of local extrema, we would say that a minimum occurs where there is a dip in the graph, and a maximum occurs where there is a peak in the graph. Endpoints do not count for local extrema. We are only interested in high and low values that are in the graph, not at one of the endpoints. So this is something to emphasize. When we use the y-coordinate of a point and when we use the x-coordinate of a point is an important factor in how we talk about relative extrema. In this context here, we don't really have temperature and time to give us clues about whether we want the x value or the y value of a local minimum or maximum. So here we're going to use this as our guide for when we use x and when we use y. This function has a local minimum value of, I can see we have a minimum down here. That y value appears to be -3. That is the value of the minimum. Where that minimum occurs, or at what x value that minimum occurs, is where we would enter the x coordinate of that point. So we could say that this minimum occurs at x equals 4. But if we are simply asked for the minimum value, we only give the y value, which is the output of the function. The same applies for a local maximum. Here we have a local maximum here, which is a peak in the graph. The value is 2, and it occurs at x equals 0 because the coordinates of that point are 0, 2. Remember that we don't use endpoints as minima and maxima, at least when we're talking about local minima and maxima. So this will become relevant when we start to talk about absolute extrema, but we would not call this a local maximum value here. Remember when you're finding your local minima and maxima to not consider the endpoints at that time. For absolute extrema, on the other hand, we do consider the endpoints and the peaks and valleys of the graph. The absolute minimum is the y coordinate. Again, notice we're talking about the minimum value here. So we're referring to the y-coordinate of the lowest point on the graph. The absolute minimum is again the y-coordinate of the highest point on the graph. If we look back on this graph that we were just referring to and try to find the highest point and the lowest point, now we are allowed to refer to the endpoints. Coming down from above, I can see that the highest point occurs here at y equals 3. I'm drawing a line all the way across just to make sure there isn't another part of the graph that might go higher. Sometimes the first point to get your attention may not be the highest point on the graph. This is similar to finding the upper end of the range. The lowest point on the graph in this case looks like it's the same as our local minimum. Again, I can draw a dashed line here where I think that lowest point is and make sure that I don't intersect the graph somewhere else where it may go to a lower point. So the absolute minimum value of this graph is -3. Again, I might be asked where the function takes on its absolute maximum or where the function takes on its absolute minimum, but if I'm just asked for the value, I just give the y-coordinate. So I'm going to say -3 for the y-coordinate of that lowest point and +3 for the y-coordinate of that highest point. Let's get some practice now finding local and absolute extrema on this graph. Pause the video if you would like to try it yourself before seeing how this works out. Local min, that's going to be a low point on the graph that is not at an endpoint. That value is going to be -3. And if I were also asked where on the graph it occurs or at what x value on the graph it occurs, I would indicate that this occurs at x equals -1. I would not give both coordinates of the point as an ordered pair, however. The minimum value is one answer. Where the minimum value occurs is a separate answer. For a local max, I'm looking for a high point on the graph that is not one of the endpoints. The only endpoint, or the only high point that really stands out to me is this one here, which happens to be an endpoint. I can't use that for a local max, so I'm going to have to answer none. Now, for the absolute min, I'm looking for the overall lowest value on the graph. Here I am going to find starting with my guess of what the lowest value is, checking all the way across to make sure the graph does not ever go lower than that value. And I'm going to say that this absolute minimum value is -3. For absolute max, I might notice this point again, and it's an endpoint, which I am allowed to use for an absolute max. But if I were to draw that line across, I can see that it intersects the graph over here where the graph goes higher than that point. And in fact, I can see that that graph continues to grow all the way up to infinity. So here I would say that there is no absolute max. I could answer this as none, or I could answer this as infinity because that is also clear. We're indicating that it does not have an absolute max because the graph goes to infinity. Here's a second example. We'll start with our local minimum. We can see this is a low point on the graph. The y value is -1. If we were asked to estimate at what x value this occurs, we might guess that that x is approximately 1.5. All we can really tell from this is that it's somewhere between 1 and 2, and it's fairly close to 1.5. Local max, again, looking for a value in the interior of the graph where it hits a high point. That local max is 3, and this occurs at approximately x is negative 1.5. For an absolute min this time, again, I might start by noticing that low point on the graph that I identified as a local min, but then I can see that that is not the absolute min because the graph does go lower than that point. I can also see that this arrow points down, and therefore this graph goes to negative infinity. So here again I could answer none, or I could answer negative infinity. Either of these answers indicates that I understand there is no absolute min because the graph goes to negative infinity. For an absolute max, I have two possibilities. One is this local max I already identified. Another is this endpoint. I just need to compare them to see which is higher. I can see that the endpoint is higher and that the graph never goes higher than this point, and therefore I would say that my absolute max is 4.